as it pertains to distributions. So we're going to do a hypothesis test using the normal distribution. And the normal distribution is like a bell curve or a Gaussian distribution or a z-distribution. If you ever hear someone say a z-score or a z-statistic, that actually pertains to the normal distribution. And then so the question we have is, if a company wants to test whether the average daily sales exceeds a certain amount, a z-test can be used under the assumption of normality. So that's what we're going to calculate, is a z-test. So we're going to answer this question using Python. And in order to execute the program, we're going to have to import 3 libraries. So the first library we're going to import is NumPy as MP, which is the numeric library. And then we're going to import matplotlib.pyplot as PLT, which is the visualization library. And then we're going to import from scipy.stats, we're going to import norm. Now norm is normal distribution, and then stats is the statistical module of scipy. And scipy is Python's scientific library. So what we're going to do now is we're going to define our variables. So the sample mean is 1050. That's mean of the daily sales from the sample. A hypothesized mean is 1,000. Its minimum sales amount is the hypothesized population mean. And then sample standard deviation is 100. And sample size is 50. Now we're going to calculate the standard error. So the standard error is the sample standard deviation divided by the square root of the sample size. Okay. Now we're going to calculate the z-statistic. The z-statistic is the sample mean minus the hypothesized mean divided by the standard error. And now we're going to calculate a one-tailed p-value. So p-value equals 1 minus norm.cdf brackets z-statistic. So CDF is cumulative distribution function. So that's a one-tailed p-value. And then now we're going to check the critical z-value for 95% confidence level on a one-tailed test. So z critical equals norm.ppf 0.95. And ppf is another function to do with statistics. So now we're going to print the results. And we're going to print the z-statistics and the p-value. So the z-statistic is 3.54 and the p-value is 0.0002. So the z-statistic, the p-value is 0.0002. It's less than a significance level of 0.05. So that means you have to reject the null hypothesis. So the daily sales exceed the hypothesized amount. But if you look at the chart, so the z-statistic is purple 3.50 and it's well past the critical region. And so the blue is your normal distribution, the pink is your critical region, the purple is your z-statistic of 3.54, and the critical value of a z is 1.64. And so the z-statistic is well past the critical value, so the null hypothesis is rejected. And then it says here, if the z-statistic is greater than the z-critical, reject the null hypothesis. The average daily sales exceeds the hypothesized amount. And we've already seen that on the graph that was printed. So now we're going to visualize the data and plot it on a graph. So x equals np.linspace brackets -4, 4, 1000. Y equals norm.pdf, that's probability density function, brackets x, 0, 1. And then plt.figure, brackets fig size equals 6, 4. And then plt.plot, brackets x, y, color equals blue, label equals standard normal distribution. And then so you're going to shade the critical region. So plt.fill between brackets x, y, 0, where brackets x is greater than z critical, color equals red, alpha equals 0.3, label equals critical region rejection zone. And then you're going to mark the z-statistic. So we're going to make some vertical lines on the chart. So plt.axv line, brackets z-statistic, color equals purple, line style equals dashed, line width equals 1.5, label equals z-statistic, and plt.axv line, brackets z-critical, color equals green, line style equals dashed, line width equals 1.5, label equals critical value. So we're going to add labels, a title, and a legend. So plt.title is one-tailed z-test for average daily sales. plt.xlabel is z-score. Y-label is probability density. You get a legend and you get a grid, and we're going to show it. And then so again, this is just another example of how hypothesis testing can be used in different ways, because in the previous videos that I made, we had hypothesis testing, which if it was less than the p-value, then it would be rejected. But in this one, if the critical value is greater than the z-statistic, then it's rejected. So you have a number of ways that you can perform hypothesis testing, and it isn't just with p-values. It's also with your z-statistic and your z-critical. So that concludes this video. Next video, we're going to be talking about t-distribution, and I hope you decide to watch it.